This time I have an Arcam Delta 170 CD transport in for service. Now, the story behind this one is the display didn't work, and the guy that owns it took it to someone to fix the display, and when he got it back, it was completely dead. We have our work cut out for us. This is a transport only. There's no DAC in this, and the fella tells me it's dead. Well, we know the display is out. That's one of the problems, and it won't open. So let's open this one up and see why it won't open. The owner of it actually informed me that he was doing some work on it. When he put it back together, it didn't work. So maybe something that was caused by the previous service attempt. So top cover open. Let's take a peek inside this unit. Designed and made in the UK. I see the little optical LED is lit up on the back here, right, for the fiber cable, or the toss link cable. That part is working. Power light's on. Okay, I saw the laser move when I turned off the power. Oh, so it closes. It just won't open. I'm thinking along the line something on this board, because all the buttons go through here to control it. You see, if I open the drawer manually and I load a CD, it will spin up and then read the table of contents. If I just tap one of these switches, it'll read up and load the table of contents. The display is totally dead. It won't open or close. None of the other buttons work. So we know that there's power getting to the mechanism, and it's trying to read the disk. The human interface, the buttons, all go through this one board on the front here. So this is where I'm going to start. I'm going to pull this board and take a close look at this board on the front here. So first I'll unplug it. Of course I got the power disconnected now, but I'll unplug the interface and the power wires. Go down to the main board, and then I will proceed to remove the nuts that hold the board in place so that I can take the board out and take a look at it and see if I can spot anything on the other side, on the component side, that might be. That should be a 1/4 inch drive, I think. Yeah, I believe there's one on each side. There's one over here too. If I remove these, this front panel, yeah, will come off. Okay, I gotta remove, then that should be another one on the other side over here. Okay, I got the screws out from the back of the display board. Lift out the display board and check it out. There's a regulator on here and a bunch of tactile switches. We all know how reliable these tactile switches can be. All it takes is one to get stuck, and everything will stop working. Okay, I've been checking this for a while. I've been just kind of going around in circles trying to see what is going on, if I've got any signals communicating from the display board down to the main chassis. The display itself is not dead. It's not lighting up, but it's not lighting up because it's not being driven by the drive IC. You see that the drive IC here is connected directly to the display, and I can bring segments up. If I give it a wet finger across the top, I can light segments up. So we know that the display itself is working, and the filaments are lit up, and the high voltage is here. So it's likely the display IC is why it's not lighting up, more than likely. It also looks like this display, or this IC, also does the key scan from the inputs here. They're all presented in, if we look at the traces for the key scans, they are presented into this IC, and then it goes out from this pin here and over through, what is this here? I can't see. It's underneath the the display. It's likely a pull-up resistor, and it's printed sensed to this pin over here, which is listed as ICD. This one RCS, that's the remote control data, which has got all kinds of noise on it until you cover it up, just because it's responding to lights in the room and stuff. We have 5 volts on here and ground, and as I say, there's random data that's appearing constantly on this, which is probably communication back and forth between the processor on the main board and this one. For example, when I press the open close button, okay, I'm making my connection, which is supplying a signal over here. We follow the trace over here to the IC. Where's we going? This one here. And that goes down to this pin of the IC. Yet I see nothing changing on the pin going over to the main controller, the main board. I see no change in the data status. I'm seeing the same pattern on my digital scope as without pressing any buttons. So it's I'm not very likely is this chip. What I'm seeing is I'm seeing the request for this chip, and the chip is not responding. Notice if I just run my finger across the top, the display itself is lighting up. So we know that the display indicator is working, and it's just not being driven on. So that IC is not running. This is the data that I get coming out of this chip. Where are we here? As you can see, it's a constant stream of data. So, and we don't know what this is supposed to be, but there's your data burst. So either this is the main controller trying to talk to this display controller and a key select or a key scan controller, and it's not getting a response, or the key scan controller is trying to talk to the main controller and it's not getting a response from that. So it could either be this controller or it could be the other one. The oscillator is running. Where is it here? There's our oscillator, 70 kilohertz, 71 kilohertz. So the oscillator's going. So the chip should be running. But say that data that I'm seeing is either this chip here trying to communicate with the other chip, or the other chip trying to communicate with this one. I get the suspicion it's probably this chip that's bad. I guess if I unplug the other board and just see whether I've got data attempting to get to this board from the other one, then we'll know for sure which direction it's going. So let's just take a look at the data coming in from the main board. It should be this one, and there it is. So the main microcontroller on the board, the main one down here, this is the connector here, this is the header, so I'm pretty sure it ends up on this one. So this one is communicating, trying to talk to the display, and the display is not responding. At this stage of the game, I'm 95% sure that this is where our fault is this microcontroller, which is going to be a custom job. If we lift up the display, we can see what the number of it is. It's a look at the number of this thing here. It's a TFK U3099 OMG. Okay, no, it's a U3090 MG, but we'll call it a U309 OMG. That's the chip. More than likely just used off-the-shelf parts. But let me see if I can find a remote code and see whether this thing will do anything when I program up a universal remote see whether I can get it to respond. Okay, we know the fact that I can control the unit using my remote control, and I can play a disc. So we know that the main processor is operational. But what's not operational is the subprocessor. Question is, why is it not functional? Is it the processor itself that's bad? Well, it very well could be. But it also could be missing a key signal, such as the clock. We know the oscillator's running, but it has to be synchronized with the main processor. And that's where Schematic comes in handy. This is IC2. This is our sub microcontroller. And as you can see from the schematic, which I was able to get off of Hi-Fi Engine, I initially looked for it and I couldn't find it, but it was because I was keying in the model number incorrectly. That's the neat thing about search engines, is that you key in what you think it is, and if it's off by one character or not formatted correctly, the search generally won't return. But when I just searched for an Arcam Delta instead of an Arcam Delta 170, I found there it was. So I have the schematic for it. So this is the processor. If we look on here, when I scoped the infrared sensor, we'll see IR goes out pin number 5, which was this one here, remote control, RC5, as it's called, pin 5 RC. And we have our 5 volts coming in on the header here. And we have this one here, it says CD, which looks like to be, one of them is clock and one of them is the data. And it looks like pin 1 is our clock, which should be that one. Pin 2 is the serial data, which should be that one. Pin 3 is our 5 volt supply. Pin 4 is, where's pin 4 on this? Pin 4 should be ground. I think, well, it should be, it's not marked here, but pin 4 is ground, pin 5 is our output. Clock, pin 1, data, pin 2. So we can scope these two, and this will give us our output. It'll give us our clock going into the IC2, and we've got our data coming out. So we should see on pin number 1, we should see the clock always running. Pin number 2, we should see data that is communicating back and forth between the two, because this is a two-way bus. It has data coming from the main controller into the subcontroller, and we have data coming back from the subcontroller back to the main controller. Also on here, this is our key input, right? Our play, pause, stop keys. They're all key scanned. There's 3 outputs, pin 16, 15, 14, 15, and 16 are our key outputs, and then these are our inputs. So if I look at the IC, I should see signals on 14, 15, and 16, which would correspond with the switches. And how it works is there's a pulse that's sent out on, and it'll be sequentially sent out. I'm going to light this flickering overhead here. It will strobe 14, 15, 16. And as it strobes them out, it's measuring whether there's a signal coming back from the inputs, from our switches. So we need to have a strobe signal on 14, 15, and 16 from the IC, and then we would have an input back, which would then be scanned and would produce the correct output. But first, let's look and see whether we've got data on pin 2. So, getting the good old scope back here. It's going to connect the ground point just so that I can easily clip my scope probe on and not have to worry about it shorting out against anything. Shield for the infrared is as good a place as any. So let's look and see whether I have clock on pin number 1. Okay, I have nothing on pin number 1. Okay, well that might be the first hint that there's a problem is I don't see a clock. I see data bursting on pin number 2. I don't see anything on pin number 1. So that's a good indication as to why it's not working. I have no clock. I'll show you the scope. So here's the pin number 2, which is the data. You can see the data from the main microprocessor trying to talk to this sub-processor. Here's our clock, and I see nothing. You can dial it down to a really low scan rate. There's nothing there. Here's our data burst. So we have no clock, so I gotta go find out where the clock signal's missing. So back to the schematic, to the main board. So this one's a schematic for the main circuit, and the print quality all of a sudden has become not as good. It's like, looks to be 6805 is the IC. Again, it's bad. I can't read the numbers here. I blew it up as much as I could, and it looks like this could be pin 25, 26, and 28. 25 being my clock, 26 being my data, and 28 being this other one here, which is going in. And I did find where that went. That was pin 6. It's going in through Q1, and it's going into the PDR. So that could even be a reset line for the this chip. So that might be one of the reasons it's not working. So let's just take a look at pin number 6 and see what pin 6 does or is doing. Is there anything on pin 6? Pin 6 has nothing on it. But what happens when I first turn it on? Does it do a reset? Nothing. Nothing's happening on pin 6. Same as nothing's happening on pin 1. Just the data burst. So when I first fire it up, actually I see a small pulse on pin number 1, but no clock. Pin 6 shows nothing. Pin 6 is held at ground. Now normally pin 6 will be pulled up through 5 volts through R14. And we know that the 5 volt rail is working because the LED works. Let's just take a look at R14. R14 is this one right here. Should we see 5 volts across it? We got 5 volts on one side and the other side has 0. So this is definitely being pulled low, either being pulled low from the rest of the circuit or being pulled low by something on here. And it goes into Q1, which is our reset transistor, right? That drives Q1. So it's being held low, which keeps that transistor off, which would mean that pin 32 would be held high because it would be fed in from this circuit here. So pin 32 on IC2 should be high. We can check that. So let's go look at pin 32 on the other side of this board. Pin 32 is that one there, and I have 19 volts on pin 32. So that's fed in. Yeah, it's off the 30 volt rail through R4. And there is a Zener diode here which will limit that voltage down to about 15 volts because it's fed off the 30 volt rail. So yeah, that's going to be about right because it's not turned on. When this transistor turns on, it should pull this low. When this transistor turns on, it will pull this low. I'm just going to try disconnecting Q1 because I'm getting some odd readings on here. Q1 may have a short. So I'm just going to disconnect it and actually measure it out of circuit. Double-sided boards, always fun to work with. Okay, let's check this transistor. Ah, we have a shorted transistor. We're shorted. Ha 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 ha. I think that might fix it. I just so happen that I have, this is a BC547, and I so happen to have a BC548, which is equivalent transistor. They will both cross over to an NTE123AP, which is just a general purpose NPN silicon transistor. I know it kind of almost looked like a PNP on this, but it's not. It's an NPN. It's just the print isn't very good. So this one here should be good. We'll just measure it first to make sure that everything is good on this one. So N. There we go, right? And this one here. No shorts on this one. It's a collector base emitter. It should be collector base emitter. Should be the basing on this one, as they both have the same characteristics. Pop that one in and solder it in place, and we'll see if this thing works. Okay, moment of truth. And it still doesn't work. All right, let me just measure that voltage again on, what was it, pin 32? And see what our voltage now is on pin number 32. Our voltage on pin 32 is 15 volts, was it? 16 volts. But this transistor now, we have on the base, we have 0.3, where we had 0 before. Emitter's got 9, so the transistor is being pulled into conduction. So that transistor looks like it's working now. I still have no display, and I still have no other buttons working on here. So that's one problem resolved. Had a shorted transistor, but that's not all of it. Now, the guy that owns this said that the display had been out for a while and the display didn't work. That was one of the complaints, was the display didn't work. But he wasn't really concerned about the display, he just wanted it to play. So this one here looks like to be the controller that controls the display, even though it's got a different number on it. This is a 86606. This one shows 6805. And this one would be a 6606, looks like. That looks to be the micro, because this other one over here, this is the main controller. And if we look, where's our remote control go in? I guess our remote control goes into this one as well. It's hard to see because it's missing on the line is missing here on the schematic. I'm assuming that goes over to here, but you see there's pieces that are missing, so we don't know what really is connected to what. Anyway, I should see my clock and data line coming out of this IC, so let's just scope this one. I believe it was pin 25, 26, and 28. One thing that is working on this chip is key scan. If I look at my output from my my key scan outputs, we have our pulses. These will go to the keyboard. This is key scan. Okay, let's look at this. I got this scope set up properly now so I can capture digital. So there's my key pulse coming off of the key scan. And if I go down to here, this is my key return. So if I push the open drawer, close, open key, open close, there's our signal. So we know that that's working. What I don't know right now on this unit is, where is the clock generated? Is the clock signal generated here by this subcontroller and sent back to the display board? Or is the clock generated on this chip? Key scan is working. The output of the key scan is working. When I push buttons, I can see the signal coming back into keyboard control, but it's not being passed on to the other unit. So I think that this chip probably is working, and that the fault is back further on this chip. Even though when I unplug the display board from the main board, I still see the data burst sitting on the bus from this chip. So I know that this chip is sending out a data burst, but there's no clock coming out of this chip, if this is the one that indeed does generate the clock, which I have a feeling it probably does. Either that or it's getting a clock from back further, but the schematic is in such bad shape, it's tough to see. It could be receiving a clock signal from one of the other chips, but again, the schematic is just terrible. Like most of the ones we find these days off the internet, when people scan them, they just don't do a very good job of scanning. And we get what we get, which leaves a lot to be desired when you're trying to trace down circuits and see where signals are missing, when you've got chunks of the schematic that are missing. Like, I can assume that this goes through, right, even though it's not there. I'm assuming that this one goes through and connects up to here, which is also connected to this resistor, which is connected into this chip here, right? These are the big question marks. One thing that does kind of bother me, this transformer does not look original. Someone's written 110 volts on it. This unit was originally set up for 240. When I look in the schematic, it shows that I should have 16 volts AC between the black and the brown. $79.5. Here's the page. The transformer clearly shows AC 16.5 volts. Black and brown, gray and red. Well, they're not showing on this because it's a aftermarket cable, but here's our transformer. As you can clearly read, someone's written 110 on here. This is transformer 1, and this would be transformer 2. This one's for the audio circuits over here. Right? This one's feeding the audio circuits. This one's feeding everything else. Clearly shows 16.5 volts and 2 volts. The 2 volts being for the display, for the filaments. If we look at that, the filament display, which we know the display works. If I unplug the power, everything lights up. I believe this is the filament ones here. I got 4 volts going to the filaments. It's supposed to be 2 volts AC. But this one here, 79 volts. So if it's 16 volts, plus or minus with respect to ground, but again, it's yeah, there's a center tap here. Well, let's see. Yeah, there's a center tap going through a 100 ohm resistor, but that goes to the decoder board. The only ones that go actually up to the display board are these ones here, but there'll still be a ground reference coming in through this other one. So with respect to ground, 0 volts, we should have 16.5 volts per leg. So go to ground, we should have 16.5 volts. We have 39 volts. 39 volts. That produces on the DC side of the rectifier, these are the 2 rectifier diodes here, that produces 48 volts. You can tell I'm getting very close to washing my hands of this unit. So we have 48 volts here, when we should have about, I don't know, 36, I guess? 48.5, that looks a little bit high. Because you see, you go over here to the rectifier. It's a 7815 rectifier, which is right down here. So we got our full voltage here, 48 volts. We've got our Zener diode, which is referenced, but of course the Zener diode's referencing at 15, but we still end up with 31. I guess that's right. It says plus 30, so okay, we're not over voltage. It just seemed to be pretty high compared to what shows here, showing at 16.5 volts. So we should see about 33 across the 2 of them. So if I go to pin 26, I've got $31, a little bit up, should be plus 30. I got 31 volts there. So that part's okay, even though input's a little bit high. Regulator's doing its job. We're just dropping more voltage through the regulator at 7815. I gotta get a hold of the guy that owns this thing and kind of let him know what's going on. I think what I'll do, I want to make sure I've got audio, so I'm going to just plug the output of this into a DAC and just run it with the remote control and see whether it is I am getting a signal. I'll use a DAT machine as a DAC so that I can just feed it into my system, because this just has coaxial and optical output. So I'll go grab one of my DAT machines and then I can just feed it right into that, as this amplifier doesn't have input. At least I want to verify that it actually does play. And I'll talk to the guy that owns it and see what he wants to do, how far he wants to go on this thing. It's certainly looking to be one of these 2 ICs. They both could be bad, because according to the owner, he said the display hadn't worked for a while, but it always did work, but the display didn't work. And that could have been this transistor that was shorted before. But nothing's working on it now. Like, none of the buttons are working, which is a problem. But we are getting key scan to the IC, but no communication between this one and that one, because there's no clock. And that is where I don't know where we've lost it, because from this shitty schematic I can't tell where the clock is being generated. If it's being generated in this one here, then this IC itself, that one there, could be the problem. But it could be that it's generated in this one, because both of them have oscillators, so either one could operate and generate the clock signal. It's very likely this one, because this also controls the display. Alright, I've got my Tascam DAT set up in digital analog mode with the coaxial input. Let's just try playing this disc and see if it plays. So we know that the player works. It's outputting a signal. It's going to my DA converter, in my Tascam DAT. The buttons on the front here are not functional. And that's due to the processors not communicating. Either the processor on this board is shot or this one here, one of the two, is problematic. Can I skip tracks? How do I do that? Track plus, there we go. Yeah, this is a little slow kicking in. When it loses sync, it takes it a second to kick in. There we go. So the CD player itself is working. I don't have an eject button on this remote though. I can't eject it without actually doing it manually. The only way to take the disc out of this is I have to actually do that. Once I've got the disc out, of course I can pop a disc in, give it a push, and away it goes. So it's kind of important that the original remote might control this. I just don't have the original remote for it. I'm just using the Harmony. So I've got to call into the owner, see if he's got the remote for it, because he didn't care whether the display worked. He said it'd be nice to get the display working. He was more concerned about the player itself. Even though the schematic doesn't show it because it's not clear enough to read. It looks to be pin 18. If I put my scope on here and press a button, I'll show you the screen. And then it'll start playing. So the IC on the main board here is receiving a signal from the remote input and it's processing it. You'll see data change on this one, I bet. Yeah, you see it's processing the data. So this chip is, I think, working. It's going to be the front. It's going to be that front chip. It has to be that front chip because I'm seeing data processing on this one when I go through. You can see it change there, right? Stop. And here's the actual remote signal itself. So seeing that, we know that this chip is alive and the clock signal must be generated on the display. This one here is passing the clock signal. We've got key scan out. When an input comes back in, we have no signal signaling this microcontroller, telling it what it's receiving. There is data on the data bus, but the data bus doesn't change when we press any keys because this chip is dead. And that clock has no signal on it whatsoever. That's just sitting at plus 5 volts. This is the data going from the display controller on the front board to the main board. It's pin 5. When I press any keys, nothing's changing. It's just the same repetitive data. Nothing's changing on this when I press any keys. It's the same data. This is probably the data from the main controller trying to tell the display what to display. I wonder if it changes when I put it into play using the remote. Oh yes, see? So the main controller is trying to talk to this one. Stop it. That leaves me pretty confident that the fault on this one is IC2. Q1 was the transistor that was shorted right here. So I asked the guy that owns this thing, I said, so what was done to it? Because he told me they were trying to service it, and it was working, just the display was out, and when he was working on it, the whole thing went dead. And here's the reply. He says, tried to get the bias voltage from the power supply to the display board. He says, the bias voltage plus 6 from the transformer to pin 30 was not present because the pin was dry soldered. The voltage is used for the display filament. If we look at pin 30 is off the second winding off the transformer. And the Zener diode there is providing a slight DC bias voltage with respect to ground, given about a plus 5 volt DC riding on the AC filament voltage, which is 2 volts off of pin 20 and 22 off the transformer. So we've got a slight DC voltage going into the center tap, which will be distributed across the filament. That's what the other guy was working and saying he had a cold solder connection. Our filament circuit on this is a pretty simple circuit. Here's our filament circuit. Got my highlighter pen if I can dig one up here. So here's our filament circuit right here. Got a resistor. Goes into the filament. Comes out of the filament. Goes through this switch. 2 different brightnesses. And off. So that's high and that's low. And then back to the transformer. That's our filament supply. Our high voltage supply for the display comes off pin 1 and 2, which is supposed to be 16 volts, but it's a hell of a lot higher than that. It's referenced to a 15 volt Zener, and we have plus 30 volts here on pin 26. I think what happened was the last guy that was working on this thing shorted something out and foobarred that IC. And now that I've heard back from the guy that brought it to me and found out that he had it to somebody else who was trying to get the display to work, before he had it, the buttons on the front worked. And when he got it back, the buttons didn't work. And now it's perfectly clear that the guy that had it before did foobar the IC. So what I suspected all along is this IC is bad. I think I've just got that confirmed. And we know that this one's okay because the remote control works. And the remote control goes directly into this one. This other IC here does the key scan. So now we know what happened on this one. Anyway, it's back together. I'll have to give the guy the news that he's gonna have to try and find a replacement IC. And I think that that's going to be a bit of a challenge considering the age of the unit. I'm not going to say it's impossible because somebody out there probably has one, but I think that finding that IC is probably going to be a bit of a challenge. Anyway, thanks for watching.